back to my YouTube channel Coding Gigs. I hope that you are loving my videos and enjoying the content, whatever I'm providing it to you, C++ contents. And I hope that it is helpful to you, all my videos, whatever I'm uploading, it is helpful. So please subscribe to my YouTube channel and please hit the bell icon so that you get the notification whenever I upload new videos. So in the last video, we have studied about what is bitwise not, bitwise and, bitwise or, bitwise XOR. So the truth tables, I had specified those truth tables in order to apply those logic while we are calculating for bitwise not, bitwise and, or, and XOR. Today we are going to study about shift right and shift left. Afterwards, we will solve some basic C++ coding questions that will comprise of this bitwise operators usage and why we are getting that output. That also we will do as a separate calculation. Fine. So without any delay, let's move with the next concept, which is shift left. Okay. So first is shift left. So remember, shift left is a binary operator, which means it requires two operands. So that two operands could be A and B. And we used plus plus. This is called as unary operand, which means only one operand is required. Fine. This was one of the concept. Okay. So shift left is represented using this operator. Okay. The first operand is represented here and the second operand is represented here. First operand specifies the variable that you want to perform the shift operation, and the second operand specifies till how many position that particular variable must be shifted towards left. Fine. Now let's say I take an example. Let's say you have a variable known as a and the value is 3. You want to perform shift operation. The value 3 is a decimal value, obviously. Now, if you want to convert it into binary value, because we are performing bitwise operator, which means bit by bit, the calculation will be performed. So, 3 will be represented as, if you calculate 2 to the power 0, 2 to the power 1, 2 to the power 2. Okay, so this is 4, this is 2, this is 1. So, the binary representation will be 0, 1, 1. Fine. And let's say I use another digit 2 to the power 3. Okay, so I represent this 3 in 4 bits. Fine. Now I want to perform shift operation, which is a left shift. So I will denote it as follows. I'll write it over here. A left shift 1, which means you are shifting the variable a, which holds the value as 3, by 1 position. Okay, so 0, 1, 1, 1, 0, 0. So this one will be shifted towards left here by 1 position. This will move here. This 0 will move here. Fine. So one vacant space will be there. Okay. So that vacant space will be, I'll tell you over here, 1, 1, 0. And here that extra 0, this 0 will be truncated, which means it will be deleted, and that truncated 0 will be, here will be the vacant space, because from here shifting started, right? So here the space was there, that space will be filled with 0. This will be the value of shift, which is the left shift. Okay. So what is the representation, decimal representation? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Obviously this is 0. This is 2 to the power 2, which is 4. 4 plus, this is also switch on. So this is also 1, which means 2. So which is 6. So this output is 6. Okay, so this is the output that you're going to get. Okay. Let's see with the help of an example. So first we will initialize a variable a with 3. We will initialize another variable c which will be holding for a time being. The value will be 0. Okay, so why do we need to declare the value c? Because the shift operation which we will perform, that is the left shift, whatever value we will get, it will be stored in c. Fine. So c will have we will perform this shift operation, left shift. Now let's see what the value we are getting of c. 6. Right. So I told you, right? So A value was 3. You performed the shift operation. It got converted into binary. Binary value of that particular left shift, the desired output what you got was uh, this, right? 0, 1, 1, 0. So this was the binary representation. So if you convert it into decimal, the value will be 6. So this is all about left shift. Okay, next is right shift. So, so right shift tells us it is represented like this. Whether first operand, you have a second operand. Okay, first operand denotes the variable where you are for which you are performing the right shift, and the second operand denotes or decides till how many positions that particular variable will be shifted towards right side. Fine. So before it was the left operator, left shift. Now we are performing the right shift. That's why this particular symbol is represented towards the left side. Okay. So I'll use the same example. A is equals to 3. The decimal value of A would be 0. Uh, 1 minute. Use this trick. 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. So binary representation again it would be 0, 0, 1, 1. Fine. So we are going to use the right shift. Okay. So what does this right shift do? The right shift is going to shift all of these digits towards right. Previously it was towards left. Okay. So when you're shifting towards right, okay, so there would be one value or one space, vacant space will be there. That vacant space will be filled with the trailing 0. Initially in left shift, here one vacant space was there because you are shifting all of them towards left. Obviously one space would be there. Here see, total 4 digits are there, right? 4 digits. In 4 digits, one of the digit will be truncated because you're shifting it towards left. And here one digit will be truncated because all the digits, 4 digits, will be shifted towards right. So you are overwriting its positions. Assume that each of this digit has a specified position. Okay, this 0 has a specified position, this 0 has a specified, this 1 has a specified position, this 1 has specified position. So when you are shifting towards right, this 0 will be overwritten with this 0. This 0, this 1 will be overwritten with this 0. That is why one space will be there. That vacant space will be uh, filled with a trailing 0. Okay. So we are performing right shift, which means we are moving this side towards right, sorry, means towards this side 0, 0, 1. Okay, so when you're moving this side 1, 0, 0, and here one position vacant space would be there. That vacant space will be filled with a trailing 0. And if you check the output, it would be 1. Why 1? Because 2 to the power 0 is 1. As I told you, use this trick to convert it. Okay, this is the easier calculation of converting decimal to binary. Okay, so the output will be 1. Okay, let's see whether it is correct or not. So you're getting the output as 1. Okay. Why 1? Because it is shifted towards right. This is the right operation. Okay. So the binary value of 3 was 0011, and after shift the binary value became 0001. So this is the output. Fine. So let's quickly recap what we have learned up till now. Okay. So we have seen what is nested if, what is variations of for loop if initialization part is removed, what is updation part, what if updation part is removed. We have seen multiple variables and multiple conditional statements and multiple updation statements been specified in one single for loop. We have seen what is the scope of a variable, right? What is increment and decrement operator, pre-increment, pre-decrement operator, post-decrement operator. We have also seen the analogy to memorize. Okay, what is exactly how the output we are going to get for post increment, pre increment, post decrement, and pre decrement. Okay, we have seen bitwise operators, where in bitwise operators we have seen bitwise unary not, bitwise and, bitwise or, XOR, shift right, shift left. So we have seen the truth tables of not, and, or, and XOR. We need to see what the operations which we perform, that is the bitwise operators, we use for not, and, or, and XOR. We need to see that. We have seen shift right example. We have seen the shift left example also with the help of a code. Now we need to see not, and, or, and XOR code also. So let's see.